Welcome everybody! This is the second part of the crystal clear electronics videos. The second chapter, Revision of Basic Physics, will be divided into 4 chapters. Our lead presenter is Mr. Béla Danyi. Can you introduce yourself, please?
Danyi Béla tanár úr. Mutatóhoz be kérlek, mondanál magadról néhány szót? Igen, köszönöm.
Hi, I'm Béla Danyi, mathematics and physics teacher at Elte Bolyai János Practicing School in Szombathely. Talent development has been in my life for a while. At first I was helping high schoolers career counseling as one of the members of Free University of High Schoolers Association. Then when I started working at Bolyai, I was practicing with talented students during workshops. I was introduced to the Crystal Clear Electronics project this year and just started to get involved in it. I'm planning to join my colleague Mr. Szabolcs Pályár's work, who is actively holding workshops for curious students from the CCE curriculums. I would say that I am just starting talent development in the field of physics. Of course, besides my job, I have other hobbies. I like doing sports, mostly football and basketball. In the past years, I've also been interested in chess. Moreover, I like to make music, I play guitar, and I sing, and in the past I tried myself in acting.
Thank you. I am Daniel Pivko, electronics engineering student at Budapest University of Technology and Economics. The crystal clear teaching materials are primarily designed for high school students, but some parts are also available for technical schools, universities, and all enthusiasts.
The second chapter was written by Szabolcs Veréb, whose personal introduction can be read on the online platforms. As mentioned before, in this part we will introduce you to the basic physical concepts. We will take a look at coherences, which are necessary to understand how the electric circuit works. Definitions and derivations will come up, but don't be scared. It's enough to understand the main ideas and connections. First, let us briefly review 3 closely related concepts in the field of energetics: energy, work, and power. The concept of energy can be approached through some illustrative examples. When fat is placed into a heated frying pan, it melts. This means that the hot pan has the ability to alter its contents, and this ability is connected to temperature. Or, a bow can only shoot arrows if it was stretched, so a stretched bow also has some kind of ability to change things. It is useful to describe the changing abilities of things with some kind of common physical quantity. This physical quantity is called energy. The common symbol is E, its unit of measurement is joule, which is represented by J. The common symbol is capital E, its unit of measurement is joule, which is represented by capital J. Several forms of energy, the ability to change things, can be observed in nature. In connection, let's take a look at the next example. For this, I will need the slope, the scar, and Danny's help. Danny, please be the car's brakes when it's rolling down the slope. Place your car on top of the slope. It has a certain amount of potential energy. Initially, it has 0 speed, so its kinetic energy is 0. I let the car go, and Danny brakes it. If we look at the problem physically, we can say that initially the car had some potential energy, but no kinetic energy. As the car moved slowly down the slope, its potential and kinetic energy started to change. Its kinetic energy increased by the slope, and its potential energy began to decrease. As we reached the ground, its potential energy did not change any further. However, its kinetic energy continued to decrease, which Danny then helped by applying the brakes. In the end, the car developed thermal energy on its wheels. I like to give this example because, apart from being a very good illustration of the different forms of energy, it shows the most important feature of energy. We cannot destroy it, we can only transform it into different forms. The concept of energy is tightly in connection with the concept of work. In physics, we can talk about work when a body is moved by a force. Work always changes the energy of something. In other words, work is a kind of energy change. This is where the 2 concepts come together. The quantitative characteristic of this energy transfer is work, which is a signed scalar quantity, i.e., it can take a positive or negative value depending on the relationship between the direction of the force acting on the body and the direction of displacement. The symbol of work is capital W, and the unit of measurement is also joule. It equals with the unit of measurement of energy, since it is energy difference. Expressed with symbols, capital W equals delta capital E in joules. It can be verified through measurements that work is directly proportional to the force on the body and displacement. Mathematically expressed, work equals F times S, where F is the force and S is the displacement in the direction of the force. Finally, let us turn to the last member of this triad, power. From the point of view of our tiredness, it is not the same whether we walk up or run up a hill. Although the energy change is the same in both cases, there is a slight difference between the two processes. We did the same work in different amounts of time. It is worth therefore to introduce a physical quantity that takes into account the time during the processes of energy change. This is called power, which shows the energy change per unit time. Its symbol is capital P, its units of measurement are watts, who are represented by capital W. Don't confuse it with the symbol of work. In mathematical terms, this is P equals delta E over delta T, which equals watt over delta T, which is equal to joules over seconds. Based on this, for example, if a light bulb has a power of 100 watts, then it means that during operation, it converts 100 joules of electricity into light and heat every second.
Thank you, Mr. Danyi, for the brief repetition. Now we will say goodbye for a short while. This was the first video of the second part of the crystal clear electronics videos. In the next video, we will cover the topic of electrostatics.
Sziasztok!